This short presentation gives a brief introduction to the concept of architectural structure and the role of structure in building. It is intended to answer the questions: what is an architectural structure and why is it necessary? And where in the building is the structure to be found? Building envelopes are subjected to various types of loading. The structure is the part of the building which resists the loads. More precisely, it is the parts of the building which conduct the loads from the points at which they are applied to the building envelope to the foundations where they are ultimately resisted. Structure is fundamental. If the structure fails, the building will collapse. Without structure, there is no building. Where in the building is the structure to be found? The relationship between the structure and the building envelope can take several forms. Two extremes are shown here. The igloo is a self-supporting dome of ice in which structure and envelope are one and the same thing. The teepee consists of a framework of timber poles which supports a covering of fabric or hide. Structure and envelope are totally separate. The timber has a purely structural function and the skin a purely enclosing function. The CNIT exhibition hall in Paris is a sophisticated version of the igloo. The 200-metre span reinforced concrete shell is a self-supporting surface. There is no distinction here between the structure and the enclosing envelope. This building is a modern version of the teepee. It consists of a non-structural profiled steel cladding as the enclosing envelope, which is supported on an entirely structural steel framework. The envelope here is entirely non-structural. The metal skin would collapse were it not supported by the steel framework. Complete separation of structural and space enclosing functions also occurs here. The transparent skin is purely enclosure, and the steel framework, the black bits, is purely structural. It also, of course, has an aesthetic function. This building is another example of the separation of structure and enclosure. The glass walls of the building are non-structural and are supported on a purely structural steel framework. In this building, which is the Nomadic Museum by the architect Shigeru Ban, all of the elements are structural. The external walls are load-bearing and consist of repurposed shipping containers. They provide enclosure and also contribute to the support of the roof, which is also supported on internal columns. Everything visible, apart from the roof surface, is part of the structure. The Centre Pompidou building in Paris is supported on a steel framework, which has a purely structural function. The external walls are of glass and are completely non-structural. The reinforced concrete floor decks, which are visible in the lower left photograph, have dual structural and space dividing functions, so there is a duality of function there. The St Mary Axe building in London has a similar structural makeup to the Centre Pompidou. The principal structural element is a steel framework, which has a purely structural function. In the plan, the structural elements are the columns, shown as black dots, that surround the central core, and a steel diagrid at the building's perimeter, the brown tubes in the photograph. The columns and diagrid are the elements that provide vertical support. The floor beams span between these groups of elements. These are also visible and partially covered by fireproofing material. The floor deck itself spans between the beams and consists of corrugated steel permanent formwork, which is visible in the upper part of the photograph, supporting a concrete floor visible at the bottom of the photograph. The grey diagonal elements at the bottom right of the photograph are part of the cladding system that supports the glass envelope and that is mounted on the edges of the floors. The structure here is separate from the enclosing element, the glass cladding, but the floors have dual structural and space dividing functions. A similar arrangement is seen here at the Willis, Faber and Dumas building, also by Norman Foster. The building has a structural armature of reinforced concrete and the cladding is glass, which has a completely non-structural and only enclosing function. In this cross-section of the edge of the building, the structural elements are the two-way spanning coffered floor slab supported on columns, and they support the glass cladding which is bolted to the edges of the floors. The structure also supports a false ceiling which is hanging from the floor slab and which provides a void for the distribution of services throughout the building. All of these elements are visible in this photograph. The relationship between structural and enclosing elements in the famous Notre Dame Chapel at Ronchamp by Le Corbusier is apparently complex, but in fact relatively simple. The building consists of a series of masonry walls covered in a cement-based material and which are self-supporting. They support their own weight and are therefore structural. They do not support the roof, which is a reinforced concrete slab with an upwardly curved edge, which is supported on a series of beams which span across the building. The arrangement is just discernible in the sketch by Le Corbusier shown here. The beams cross the building and are supported on two rows of columns which are located within the masonry walls, but which are separate from the walls. The roof slab is attached to the undersides of the beams, which are concealed behind upwardly sloping edges of the slab. The walls of the building do not, therefore, support the roof. The columns that do support the roof can just be seen here in the gap between the top of the wall and the underside of the roof slab. There are, therefore, two independent structures here, the walls, which support themselves and provide enclosure, and the reinforced concrete frame consisting of columns and beams which support the underslung reinforced concrete roof slab. Everything which is visible has a structural function. The Guggenheim Museum building in Bilbao has a complete separation of structural and non-structural elements. The non-structural metal skin is supported entirely on a steel framework of very complex geometry. In this building, the Antigone building in Montpellier by Ricardo Bofill, there is a reinforced concrete structural armature, which is a load-bearing wall structure rather than a skeleton framework. This is a multicellular building in which the internal walls have dual structural and space-dividing functions. The external cladding walls support their own weight, but depend on the reinforced concrete armature for lateral support. They therefore have a dual structural and enclosing function. The structure of this building is therefore fully integrated with space-dividing and enclosing functions. The humble brick and timber house has a quite complicated relationship between space-dividing and enclosing and structural elements. The timber floor joists are structural and support the floor surface and ceiling elements, which are non-structural. The joists span between parallel sets of walls which have combined structural and space-dividing or enclosing functions. In the roof, the timber trusses are structural elements which support the non-structural roof skin material and which are in turn supported by the external walls. This general arrangement is seen throughout the entire history of Western architecture. Here is another example from the 19th century in the Marchmont district of Edinburgh. These tenements have load-bearing wall structures. The walls which are vertical in the plan are the load-bearing walls that carry the weights of the timber-joisted floors which span between them, as in the previous building. The non-load-bearing walls that run in the horizontal direction in the plan also have a structural function because they act as bracing, which prevents the building from falling over like a pack of cards. So all the walls in this building actually have a structural function, and they also have space-dividing or enclosing functions. There is complete integration of structural and space planning. The few examples given in this short presentation illustrate the principles that relate structure to architecture, which are that all buildings contain a structure, the form of the structure must conform to that of the building taken as a whole, so the act of designing a building is also an act of structural design. The structure is a bulky object which cannot easily be concealed, and which affects the appearance of the building. The relationship between the structural and non-structural parts of the building can take a variety of forms. Sometimes, as at the Guggenheim Museum, the structure and non-structural parts are entirely separate. Sometimes, as in the CNIT shell, the enclosure and structure are one and the same thing. Often, as in the tenement buildings, structural and space planning elements are entirely integrated. Sometimes, as in the Centre Pompidou and WFD building, there is a mixture of dual and multifunctional elements, some of which are entirely structural, some of which are non-structural, and some of which have dual functions. Whatever the combination that is adopted, the design of the structure has to be fully integrated with that of the whole building.